Hi, so today we're going to be working on an airboard with no backlight. Since I've done this a million times, I'm going to take the liberty of doing these videos a little quicker and not walking through the schematic with everything. So if there's anything that you don't understand, feel free to go back to an earlier video and you can see what I'm referring to, and you can see where I'm talking with schematics and all of that good stuff. So one of the things you're going to notice under the microscope here is that even after a thorough ultrasonic cleaning, that this board still looks like complete and utter dog shit. So this is the LCD connector. That's complete shit right there. The entire area actually kind of looks really crappy. You know what one of the funny things, though, is going to be about this board? You know what the funny thing is going to be? Is that the backlight fuse is actually going to be good. I'm not kidding. So watch here. Wait, let's see if I can get this within... Alright, so where I have the camera right now, it's damn near impossible to actually see the multimeter. But anyway, so you'll hear it beep. So I'm going to put it in beeping mode. We're going to touch those two probes, and it fucking beeps. I mean, again, you can actually burn this, and this is one of the things about the LED driver circuit in MacBooks. Like, that fuse is almost, especially in the Airs, it does not go bad. So one of the things you're going to notice is not only is the LCD connector itself physically burned, but you're actually missing a ball under the LP8550 that's needed for feedback. See that? See how you have 4 balls and one of them is just kind of gone? Let's see if I turn the light up if you can see it a little bit better. Yeah, you can see that little brown piece of crap, and that's what used to be a pad. So right there, yeah, you can see a little bit of redness, and that little redness is where there used to be a pad. So one of the things that we're going to do here is I'm going to desolder that chip, and I'm going to pray that on the other side I can scrape away and that I have a pad. Because if I don't, I have to run a wire into the chip, and that shit is miserable. So you notice that's also this picture looks better. It's because this is a microscope that iFixit sent here. Again, as I've said in a few other videos before, I can now see through both eyes of the microscope instead of just one. And that is because instead of having a $300 microscope, I now have a $900 microscope. And that is because iFixit sent this thing here. So I didn't pay them for it, and I don't work for them. So one of the ways you can give back if these videos has helped you is to go to the iFixit Answers section and answer a question. I'm not telling you to like them. I'm not telling you to buy from them. I'm not telling you to... I'm honestly not even telling you to be nice while you're answering the questions. Just go there and answer a question. It's the least you can do out of the just respect for the fact that they've made my life a lot easier and they've made my ability to make this content a lot easier. So my flux syringe is completely destroyed. So this is as unprofessional as it gets. So I dipped this thing in the flux, and now I'm rubbing it on the board. That is not how you're supposed to do this. That is not how this gets done. That is just me being unprofessional. And you can troll, and you can bitch, and you can whine, and I don't really give a fuck because I know that what I'm doing is going to work. And I know that I don't really care for your particular opinion. So there are a lot of trolls on this channel. They're like, I can't believe you do X, Y, and Z. It's like, yeah, I can't believe that you're sitting here bitching about me doing X, Y, and Z instead of making money doing it yourself. So I'm going to get some solder, wick, and a little thing to cut my wick so that I can get to work on this. So I put some flux down to make it easier to remove that solder, and I'm going to use a flat chiseled tip on my iron. So my iron is a Hacko FX951. That's actually the station of the iron. The iron itself is the FM2027, which is pretty good stuff. And this flat chiseled tip. So I do that. I drag the wick. This is something that a lot of people at the school had trouble with. They were moving the iron. You don't move the iron. You push down with the iron, and then you move the wick. And then it simply drags it across. And let's see. Do we have a ball there, or do we have shit? Oh my god, I think we might just have that ball. We might just have that space. So that, you can tell that this kind of got fucked from over here, because this is where it comes from. And you can see that at that point, like, this is healthy, right? So these are probe points that are nice and healthy. These are probe points that are fucked and sodomized. See? Healthy, fucked. Healthy, fucked. And that's what we're trying to avoid. So let's see. Again, I used to be able to do 10x, 30x in the other microscope kind of sucked. This one goes all the way up to 45x, and it actually looks good at 45x. The one thing that you notice, the weak point at 45x is just how much my table shakes, because I have a cheap-ass IKEA table. So I don't really feel it in my hands, but you can clearly see it. It sucks. So what I'm doing here is I'm just scraping away a little bit. Let's see if that actually has continuity. I don't want to scrape too hard because that is a corroded pile of crap. What I want to do is I want to see if there's actual continuity between this and this. I give up. I can't do this without a schematic. I need to show you what it looks like. Somebody told me recently that I should make these videos a little shorter because more people would be likely to follow them, but I don't feel natural doing that, and I'm not doing these videos for clickbait. I'm doing them to actually teach something, so fuck not explaining things. So here's the backlight boost circuit here, right? So this is confusing. I've explained how a DC to DC boost circuit works in many other videos. You can watch my videos on how a DC to DC boost circuit works. It's in the Logic Board Repair playlist of the channel. What I want you to look at here is this is where 12 volts comes in. It's going to come in here. It's going to get boosted over here, and then this is where the actual output goes. So where do you think the most damage is going to occur? Where there's 12 volts or where there's 40 or 50 volts for the backlight? 12 volts or 50? 12 volts or 50? If you're thinking that most of the damage is going to occur where there's 50 volts, you are indeed correct. So here is something called a feedback line. So most amplifiers, most boost circuits of any kind, what they do is they want to see what it is they're actually doing in order to continue boosting. So over here, you see that there is a feedback line going to the output, and this is also where the 40 or the 50 volts is going to be for backlight, depending on your machine. On the Airs, it's going to be a little lower, something like 23 to 27, depending on what you set the brightness at. Either way, this chip is not going to do shit if it doesn't see what it's doing on the output. It wants to actually know, okay, I'm doing the boosting over here, but what is the result of my boost? I want to see what it is I've done. If this chip is making 70 or 90 volts, it's going to shut off. If this chip is making 13 or 15 volts, it may tell itself to turn itself up a little bit. That's the way this works. Now, since this is the part where there's the most voltage, this is the part where the most clusterfuck is going to occur. So that burned ball and that nasty looking trace is this one. And that crap by the backlight is happening over here on the connector. So the connector and that trace were what got most messed up. That's where the damage occurred. So we are going to go over repairing that, and that's pretty much what I'm looking at under the microscope. Okay, now back to fun, and back to my shaking table. Again, that's not the microscope's fault. That is my fault for having shitty IKEA furniture in my office, because I'm a cheapskate. So this over here, let's just scrape away and see what it's doing. So I'm going to get an iron tip that's a little better at scraping. And while I'm switching the iron tip over, the station is going to beep at me. So what Hacko does is they program their stations to be as annoying as possible and beep as loud as they can anytime you're changing tips, because somehow they think that users actually like listening to that shit while they're adjusting their station. That's engineers for you. Okay, so that was pretty much gone. So I barely touched that thing and it's gone. What this tells me right here is that if I were to actually, if I were to do anything to that chip, or I was trying to try to solder something to there, what this tells me is that that would have lasted for all of about 5 seconds before the customer came back for warranty and filed the charge back and told me to go fuck myself because my repair didn't last. So you may be looking at that and saying you broke it. I'm looking at that saying that would have been broken anyway, so it's better to find out now. It's the same thing with ultrasonic cleaning. You have these people that are afraid to put boards in the ultrasonic because they think that the ultrasonic will actually make it worse. And here's the thing, if the ultrasonic is actually going to rip something off of your board was probably not stable to begin with, and that's something to think about. So what I want to do here, remember how I said that the feedback is going to attach to the backlight output? Well, the way this works on this board, let me just get that a little bit more into focus. I'm still getting used to the new microscope. There we go. So it's going to go from, this comes from the other side of the board, right? So this thing right here, from right where the backlight output is. And somewhere in there, that goes to here. So I want to see if this beeps to that. If this beeps to that, when I say beep, I mean there's continuity, meaning that the electricity can pass from this to this with no resistance, then I can just simply put a little line over here and be happy. Whereas if it doesn't beep to that, that means I have to run a wire from here to here, which is a much bigger pain in the ass. So I'm going to put my multimeter in a mode in which it will beep if there's electrical continuity. That's a nice beep. You probably can't hear the beep because I had that right next to the air filter. So that's good. So what I'm going to do right now is do something a little bit ghetto. I'm going to extend that a little bit using a little piece of wire that I take off of a battery. So just so you can see what that looks like here. So I have wire that I'm taking off of a old MacBook battery. I open up one of the strands, I open it up, I cut it up, and this is excellent for my application. So I'm going to add some solder to that via. With that or a little piece of whatever clusterfuck copper that is that's left. I left the smaller tip, my smaller tip. I got so happy that I got the smaller tip that worked perfectly and was bent, and I left it at the fucking hotel that I was doing the soldering school in. It wasn't meant to be. I knew it. It just wasn't meant to be. So here's what we're going to do here. This is bullshit. A lot of people ask me, how do you cut the jumper wires to a precise exact length? Well, I use my J tool. So you know they got the G tool for the iPhone corners. Yeah, I use my J tool and my jumper wire tool. I wiggle and it's the utmost professional way to do it. See how fucking professional that is. Oh yeah, I'm totally confident that that is not going to move away one bit. Then we use our professional flux applier. I really do need to get the new thing for my syringe. I really didn't. I had no concept of just how much shit would get lost by students in the class, so that when I came back to do my regular work, just how few things I would have compared to what I left for the fucking class with. Anyway. So, let's put an LED driver on. That is a clusterfuck of flux there. I gotta get to ordering all these little things that I left at the hotel or that got sodomized. Boo, I don't want you there. A little dab of solder. I either want the pads to be flat or to all have solder, but not one be flat, one have solder. That's not the right tip to use, but I didn't feel like changing it. Now this is where this gets really unprofessional. So instead of brushing it to get the flux evenly distributed, I'm actually just going to use the LP8550 as a brush. That is way too much flux. That is way too much flux. I mean, when I say too much flux, I mean way too much flux. So I'm going to hold the iron away. This is the part where I think it's kind of important that you see what I'm doing. So I'm going to start from far away. I want to kind of try and burn the excess flux off of the board. so that doesn't happen. So again, the air is not what's blowing the chip away. The flux that's being moved is blowing the chip away because that flux is tacky. It's heavy. So when I'm moving that heavy flux, I'm also moving the chip, which would not be moved itself by just the hot air alone. So I'm blowing away the excess flux. I'm heating it up nicely. I'm taking my time with it. I got all the time in the world. And they're coming closer and closer. Might as well give you a better view. Let's, that's a better view. Move this thing out of the way. You don't want to touch it when it gets hot. If you touch it, you'll fuck this whole thing up. Eventually, you'll see that most of the flux around the chip goes away, except for maybe half a millimeter out in every direction. When you get to that point, that's when you go in on the chip for the kill. So obviously, I'm going to break that rule a little bit here because there's too much flux everywhere because it got added like a mess. But see how on every side of the chip, there's kind of there's only like a half a millimeter sticking out. Once you're at that point, you're good to go. You've gotten rid of most of the excess, and the chip's not going to run away. You can get in close on it, and then do this. Now see how I'm moving the iron back and forth? That's so I can see the chip dancing. You see how it's moving back and forth, moving back and forth, moving back and forth? That's how I know that all the balls are liquidous, and that's how I know I got good joints, and that's how I know that I'm good. Make sense? So that's how you solder an LED driver. And I'm pretty sure that my makeshift ball is going to work just fine. So see, remember, I don't have a solder pad on the board at that point. So again, I have two choices. I can waste a ridiculous amount of time making a pad there and then have to deal with all the other bullshit in the backlight circuit later. Or I can simply cut a wire, put it there, and solder right to the wire. The second one is always the most practical. The first one is the one that is correct to do, but the correct way to do it is a complete and utter waste of fucking time. So the correct way can go screw itself. Now what else do you see wrong with this if you take a look? What looks messed up here? If you're thinking this, you're very, very right. So let's see what that does. Now this chip needs 3 volts at the enable pin in order to turn on. If you don't know that, you can just find a data sheet for LP8550. Once you give it 3 volts at the enable pin, it turns on. But this is a circuit that runs off of 12 volts. You're boosting 12 volts, you're sending 12 volts in here for everything, so where are we going to get that 3 volts from? Well, the way this machine is set up is that when these enable signals are here, it opens this transistor which sends 12 volts through the boost circuit. So why don't we just reuse that for this? Because we can't send 12 volts there. I don't want to make a new circuit depending on EDP, backlight, enable, and backlight platform reset. I don't want to make a new circuit like this just running off of a separate 3-volt line instead of reusing my 12-volt line. So what do? I use a voltage divider. If you don't know what a voltage divider is, you can look at the What is the Voltage Divider video and find it. And you have right over here this voltage divider, R7731 and R7715, which are going to here. Now, which one of these do you think is going to be messed up? Do you think the side going to ground is going to be messed up? Do you think the side over the second side of the top resistor is going to be messed up? Or do you think the actual side that's coming from here where the 12 volts is going to be messed up? It's going to be the side where the 12 volts is because that's the highest voltage. Not the part where there's 3 volts. Not the part where there's 0 volts. Right over here. The surge was ting. And when that surge goes through here, it fucks this thing up over here. So let's see what the resistance is of that resistor. So I got my multimeter over here. I don't know where to put it so you can see it with how I've arranged my desk. Let's see, can you? No, you'll never see it over there. You might see it over here. Obviously, I can't keep this shit here, but... the motherfucker. Okay, now you can see it. Now I can't see it, but what the hell. Hacko wants to be in the way. So that thing's supposed to be 200 kiloohms. Do you think it's going to be 200 kiloohms? Oh, we're still in beeping mode. We're at infinity ohms. The other one is at least measuring the 100 that it's supposed to, but this one over here at the top, not only does that look nasty, but oh, okay. We almost had something there. 242, 150, 170, 147, 148. 150. Okay, let's see what we get there. So that area, again, this does not look nice. So let's just see if I can make it look a little nicer. Add some solder. We get the world's least professional flux syringe. That is shameful. You guys who are watching this video, you're going to be better than me. You got to be better than me. Make sure that you get your flux syringe that works with the tips that work back from students. So there's no making that look nice without taking that off and properly scraping it. Which means I'm going to take it off. Because Lord knows this will be back here in a day if I don't. And Lord knows if I don't replace that, that is no good. All right, so. I mean, you may think I'm not being nice to it, but if it's going to break from this very basic going over it with the solder ball, then it's not going to last for the customer. This is not how you apply flux. Okay, they're moved into place. Now for that LCD connector. This is the fun part because I get to see how my fixed FR801 from Hacko removes an LCD connector. Turn our heat and our air up because this is a lot of big ground plane over here. There are people that would actually leave this on the board. I've met them. I've met them. They'll fix something right. It'll actually work, you know, for a week or two. I'll give you a hint what the name is. They rhyme with fuck you. The name of their store rhymes with fuck you. I think they did that on purpose, making the name of their business rhyme with fuck you. Clean off the shit on that pad. This is a nice solder with a nice flux inside of it. This is a fucking barbaric way to do it, but when you have a nice Kester solder that has a really good flux built into it, See, now a lot of people would think that that pad is gone, right? It's not gone, it just needs to be cleaned. And all the thing is, flux cleans oxide and crap and bullshit off of the board. So you do this, and you have the benefit of the heat, and you also have the flux, which is made to remove it from the board. So this is good stuff. Okay, now we go over it with the wick. Again, wick is $5 for a roll. That's when I'm being lazy and buying it in the US and not caring who I'm buying it from. So cut the end off of the wick and always work with a clean wick. You push down with the iron and you pull with the wick. So I'm pulling along with the wick. I'm not scraping with the iron. Scraping with the iron is bullshit. You push down with this so that when you pull the wick, you have control over it. Pushing with the wick, pulling with the wick. Oh. Here's the thing. This is 99% chance a good component. I simply don't care. If you look like that, and a lot of people go, how do you test a component? How do you know that it's bad? What do you measure? Well, my eyes measured it. My eyes told me that it doesn't belong on my board. See how that works? Okay. Eyes are an excellent measurement tool. Okay, so now we get on to cleaning. Now this is an area where a lot of people troll. I have a brush, but I don't like the brush as much as the Q-tip, and I want to talk about why that is. See, the brush just kind of spreads this shit all over the board, whereas the Q-tip actually absorbs this nasty crap. And I like the absorption. Now, the problem a lot of people have with the Q-tip is that they say that the Q-tip leaves fibers on the board. And you're absolutely right. If you rub it back and forth, it totally leaves fibers on the board. Whereas if you spin it like this, it doesn't. See what I'm doing? I'm spinning like this. When you do this, you don't leave any fibers. If you do this, if you move back and forth, you will leave fibers like crazy. However, if you preheat the board before cleaning so that the shit is not incredibly sticky, and then you just roll the Q-tip like that, what you're going to notice is that it gets rid of a lot of the junk. And instead of just spreading it to other parts of the board, you can get it to a point where it's really, really clean. So I heat and I heat and I heat. After I've heated, I dip my Q-tip in alcohol. And after that, I spin. I'm not interested in cleaning the entire board right now. The ultrasonic will do that after I'm done. And also a brush. There, the brush is actually going to work because the junk is going to have something to go. It's going to be immersed in an ultrasonic bath, it's like 60 Celsius with a cleaning agent that's actively rubbing against it. So there, a brush is a good thing. But here, the brush is just going to take the flux and the nasty shit, and it's just going to move it all around, and there's really no point to that. So I just want a clean area to solder my connector onto. You can't solder a connector onto a nasty board. But now I'm moving it back and forth, and I know I'm not going to get fibers on the board because I've removed all the dirt. There's no sticky shit. If somebody could invent a Q-tip that did not have fibers that came off, they would make a ridiculous amount of money from the small device repair community. As anybody who's a regular of this channel knows, there's nothing I hate more on planet Earth than soldering small connectors. Now the newer ones are cool compared to the older ones because they have they actually use the holes in the board. So see, there's something under it that keeps it from moving around. So what I'm going to do is I'm going to put flux on the sides, and I'm going to solder the sides on first. So unprofessional. So fucking unprofessional. As soon as I'm done with this video, I'm going to buy a proper syringe. Now, here's the problem. I need to hold the connector in place on the board. And I need to hold the solder to rush it in. And I need to hold this there. But I have two hands. And this limits me. So I'm going to put solder on my iron. Now the problem there is that the flux is going to flow away from the solder. So it's going to be all gooey, which is why I put flux on the board, so that now I can use one hand to hold the connector down and in place. And again, you want to be holding it nice and hard on the board, because it has to be making good pressure for my soldering technique to work. And we're going to put it down on there. Okay. Got it. See? Now we do the same on the other side. Again, see how this give? The pads are going to be easiest to solder. The pins are going to be easiest to solder when they're making really, really tight contact with the motherboard. You don't, and there's going to be no gap between the pin and the board, and the solder is going to just flow beautifully. That's what we're looking for. Now to get in there, I need my bend tip. By the way, this is why I like bend tips, and I'm not a big fan of the straight ones. Look what my bend tip is going to be able to do. It's going to get right in there. Come on, heat up. Every time my Hacko heats up, it beeps. Gives me a loving beep. That is a mess, of course. I'm going to add some solder to the tip of my iron. I'll hold this down as hard as I can. I accidentally held it down as hard as I can on the plastic part, but nobody's going to give a shit. Push. Way too much flux. That is gross. That is not how you do it. That is how you do it when somebody stole the tip to your syringe. Move it back and forth. I want to get my hand in a certain spot, so I just have to wait till it stops shaking. Alright, let's make another go at that. So that is really not good. And instead of pause, edit, and do another video, I'm just going to fix it, because that's what you have to do in the real world. This would also be easier if I had the smaller tip to get in there, because I had a really small bend tip, and I'm confident that that is at a student soldering station in Victor, New York right now. Anyway, that'll work. I can't say that it's perfect, but that will most certainly work. It's not a soldering joint that's going to go in a museum by any means, but it will do when I don't have my proper tip. Alright, so we're going to go one by one here. Dough. And then when I give up on one by one, which I always do, I go. Those two are okay to be tied together. That's backlight. You want to get the iron in between the pin and the pad and get them both hot, and then kind of shove the iron in between and shove the solder in between. This is easy when your tip is not the size of your finger, but what the hell? If I'm going to use a tip that's the size of my finger, I might as well use solder that's the size of my finger. Make it match. That is awful. Whoa. That is just bad. This video should really show that if I can solder a connector, that anybody can. Because this is just stupid. Like this is a 90-second procedure. This is a 30-second procedure. I'm dragging it out to take up almost an entire fucking video. I should just use the fuck it. If I don't have the right tip, I might as well use my chisel tip to do those stabilizing pads. When I say stabilizing pads, I mean the ones at the ends. Heat. You're going to heat, and you're going to beep. Beep. Good eye. Better. The important thing here is on the back you want it to be stable. On the front, the priority is really to not get the fucking solder inside the LCD connector. Because if you do that, and this is more important if you're doing this for a repair shop or a do-it-yourself user, what they're going to do is they're going to plug the LCD connector in, and it's not going to get in there because you put too much shit in the fucking LCD connector. You put too much solder in there. So what's going to happen is they're going to keep trying to plug it in over and over again, and eventually they're going to break it and destroy the board, and they're going to rip every single pad of the LCD connector off with it. And they're not going to be happy. And then when you have to fix it again for free, and you're not going to be happy. So in that situation, nobody's happy. So get rid of that water damage sticker. I know that you're water damaged. I don't need to. You want to have control of the Q-tip. You don't want to let any of those fibers stick on the board. People say, you know, it's not good to use a Q-tip again because it keeps the fibers on there, but are you in control of your Q-tip, or is your Q-tip in control of you? There may be one or two fibers on there, but it's not going to survive the ultrasonic cleaner and also the brush. Wonder if I have a light. I just touched a really nasty fluxed part of my desk. Ugh. I'm plugging just enough in to see that there's a light. So what do you think I'm going to get? Backlight or fire? Suppose one way or the other it will light up. I forgot, this is the 2013 and 14 Air does this stupid crap where it turns on, turns off, turns on, turns off, turns on, turns off, and then turns on again. So let's see. What are you going to do? Hey, what do you know? It works. Which is pretty damn cool. Alright, so now we have ultrasonically cleaned it, so let me show you what it looks like when the job is fully done. So you remember what this looked like before. How it was missing a ball. Now it looks like this. So that is my wire that I ran straight through to the ball. So my wire is directly making contact with the ball. And this is pretty cool. You really didn't get this level of detail in the old microscope. So again, say thank you to iFixit for that, and answer some questions on their answers form. And if you want to, I do not get paid by them for this. I just got a microscope in the mail for free, unsolicited, so I figure you should send them some unsolicited help in their own answers form. It's the nice thing to do. Anyway, take a look at this. So again, this ball doesn't exactly look as nice as the others because it's a ball that's been combined with a piece of battery wire that I had covered in flux, but yeah, this is a completely usable job. You saw that the backlight worked when it was done. You saw how I troubleshooted, what I replaced, why I replaced the things that I replaced. Yeah, and I'm not going to say that that's the nicest thing in the world over there. But it is functional. It does work. That's the backlight enable resistors. You saw what this looked like before. Burned crap. Now it's usable, it works. Again, you don't leave the shitty looking LCD connector on the board with all of its shittiness. That is something that a place that, again, the name, that is something you do if you are a shop whose name rhymes with fuck you.